Hi student. In this session we are going to discuss about configuration and amplifier. That is BJT configuration and BJT amplifier. Okay. What is configuration? How many terminals are there in amplifier? Everyone know 3 terminals. What are there? Emitter, base, collector. Okay. 3 terminals, emitter, base, collector. But if you are giving a input connection to that particular amplifier and if you want to take a output, we should need 2 points to give a input and 2 points to take a output. How it's possible? Among these 3 terminal, we will take any one terminal as common terminal. If you are taking emitter as a common terminal, that is called common emitter configuration. That is simply we can call it as CE configuration. If you are taking base as common between input and output, that is called a common base configuration. If you are taking collector as common between input and output, it is called a common collector configuration. Now you people know what is configuration. Actually, transistor consists of 3 terminal. If you are giving an input and if you want to take output, we should give between 2 terminal. So among the 3 terminal, anyone taken as common between input and outputs. This is about configuration. Next. Okay, fine. Okay, fine. We have idea about common base configuration, common emitter configuration, and common collector configuration. Next. We will see one by one. First one is common emitter configuration. So we already said, actually, transistor consists of 2 types of classification, NPN and PNP. Okay, now we are taking NPN transistor for CE config to explain about the CE configuration. Okay, see here the emitter terminal is taken as common between here. This is called as input. This side is called as output. We already know the input side is always forward biased. The input side is always forward biased. The output side is always reverse biased. Okay. Here, see the base terminal. Base is positive. That's why to give a forward connection, positive to positive connection, that's why here the battery connection is positive, negative. The collector is connected with negative. That's why we are giving reverse bias connection. That's why collector is connected with positive and negative. Now, to explain about a configuration, you should know about the input side is always forward bias and output side is always reverse bias. We are taking NPN configuration. To simply draw the diagram, we should this symbol we must draw this symbol, then only we will give a battery connection. So if you are drawing the diagram, people can able to explain the diagram very easily. See here, this is the input side, no? This VBE and VCE is called a bias voltage. What is bias? We are giving some certain output voltage to the transistor work properly. That is called a bias voltage. Okay. Here, input voltage is VBE. In common emitter configuration, input voltage is VBE and input current is IB. If you consider the output side, that is output voltage is VCE and output current is IC. Output current is IC. Okay. After giving a connection, we should note down the input voltage, input current, output voltage and output current. So, while I'm discussing about the configuration, we should discuss about the characteristics. What is characteristics? The pictorial representation of the voltage and current relationships called the characteristics. If you are drawing input voltage and input current relationship, that is called input characteristics. If you are draw a graph between output voltage and output current, that is called output characteristics. Okay, now we will see one by one. So keep in mind that in a configuration, why it is called a configuration? Any one terminal is common between both input output. The input is always forward bias, output is always reverse bias. Based on the type of the material, we give the battery connection. This is called a bias voltage. What is bias? To make the transistor working, we should give some external voltage, that is called a bias voltage. After giving voltage, a current flow is occur. So after a current flow, we should note the input voltage, input current and output voltage, output current. Now we will see the characteristics. See here, in the input characteristics, I already said to you people, input characteristics drawn between input voltage and input current. See the diagram. What is our input voltage? VBE. What is our input current? IB. See here, input voltage and input current IB. Okay, input voltage and input current. Then we keep this VC. That is, what is VC here? While you are drawing the input characteristics, we should keep, this is the output voltage. This is the output. VC is the output voltage. We should keep output voltage as a constant one. Okay. So, in the input characteristics, we drawn between the input voltage and input current. That time, we should maintain that output voltage as a constant one. What is the output voltage? See here. What is the output voltage here? VCE is the output voltage. So, we are making output voltage as a constant. So, this is a different output voltage as a constant value. If you plot a graph between input voltage and input current, we will get the graph like this. Okay, now we clear about the input characteristics. So, while you are writing an equation about input characteristics, Rin equal to, that is, we know the V equal to IR, that is Ohm's law. So, R equal to V by I. R equal to V by I. That is a input characteristic VBE. Input voltage. Changes in the input voltage with respect to the changes in the input current with the output voltage. Constant output voltage with the constant VCE. Okay. Now you clear about the input characteristics. Next, output characteristic. What is output characteristic? A pictorial representation of the output voltage and output current. Okay. A pictorial representation of a output between the output voltage. So we draw the output characteristic between output voltage and output current. Okay. So what is the output voltage? We know the output voltage is VCE and output current is IC. See the circuit? Sorry. See the circuit? The output voltage is VCE and the output current is IC. To draw the output characteristics, we should keep the input current as a constant. Okay. output voltage, output current, input current as a constant. See the graph, output voltage, output current. This is the input current. Input current as a constant one. So this is what we have to draw the output characteristics. So R out equal to changes in the output voltage divided by changes in the output current with constant input current. Okay, now you people will get a clear idea about the output characteristic. The same way we should draw these graph structure, input graph structure and output graph structure, and the writing of R in and R out value. It's the same way we should write for all the configuration. Okay, now we will move to the common base configuration. Before going to the common base configuration, we also discuss about the amplifier. We all know what is the major application of the transistor. The application of the transistor is working as an amplifier. It's working as a switch. But in our syllabus, we are having the amplifier, common emitter amplifier, common base amplifier, common collector amplifier. We people know the similar way. This is an example circuit for common emitter amplifier. This is the DC voltage, external DC voltage to apply the transistor working. But this is the input, AC input signal given to the amplifier. So what is the amplifier? What is called a amplifier? It increase the signal strength. Signal strength. Okay, the transistor increase the weak signal strength in terms of voltage, current and power. Okay, a transistor increase the weak signal strength in terms of voltage, current, power. If it is a, we will see the classification amplifier next session. It's also available in our syllabus. So here the amplifier, we are giving the alternate current as an input, IB, that is alternate current as an input signal. So during the positive half cycle, it is forward bias and we will get the output across the collector terminal. This is a common emitter configuration. Then during the negative cycle, it is in a reverse biased condition. So, but it is always in a to work as a correct way. It is in a forward bias, it is in a reverse bias only. This battery connection giving that forward bias and reverse bias. So that giving negative signal. So give the output is in the reverse direction, increase in the voltage value in the reverse direction. While having a positive signal, it will increase the output voltage in the positive way. In the negative direction, it will increase the output voltage in the negative way. This is a amplifier configuration. The same way in the amplifier, that is input characteristics and output characteristics, everything is same. In our, if you are asking the big question in a common emitter amplifier, you people draw this diagram and explain whatever the input you people, this is called DC voltage, this is about the alternate current input signal. Then whatever the input current and output current, input voltage and output voltage, everything you have to explain. At last we should equation. You should mention 3 equation. What are their? Voltage gain AV, voltage gain AV, AV equal to output voltage divided by input voltage. What is the output voltage here? VCC divided by VBB, or else we can call, otherwise if you are mentioning in the terminal wise, VCE divided by VBE. If you are seeing some textbook, they are mentioning like this. What is current gain? In a common emitter configuration, we are mentioning the current gain value as alpha. Alpha equal to the current value equal to output current divided by input current. Okay? Output current, that is I out. Output current divided by input current. Okay? IC by IB. This is about alpha. That is, this is about the current gain. we should mention these three equations for all the amplifier. For power gain, it is mentioned as a AP. It is voltage gain into power gain. Okay. Now we will clear idea about the common emitter amplifier. Now we are moving to the common base configuration. Here base is common between the input and output. This is a configuration explanation. This is NPN. So the base is connected with the positive. See here the emitter is connected with the negative. So here we have to give a forward bias. Negative to negative connection, there is forward bias. Here collector is connected to negative. So here we are giving reverse bias, that is positive to negative. This is about a common base configuration. So here also we note down the input current, output current, input voltage, output voltage to draw the input characteristics and output characteristics. See the input and output characteristics. It is drawn input drawn between the input voltage and input current. See the input voltage. What is the input voltage here? VB is the input voltage. What is the input current? IE is the input current. Okay. IE is the input current. To making the output voltage as a constant. What is the output voltage value here? VCB is the output voltage. Okay, fine. This is about the input characteristics. Next, we are moving to the output characteristics. How we draw the output characteristics between the output voltage and output current. Okay, see here, see the circuit. What is the output voltage? VCB. What is the output current? IC, to make constant input current. Okay, so see here, this is a making input current as a constant. This is the way we have to draw the circuit. Okay, see here they mentioned the cutoff region, active region, saturation region. So see this, if your transistor, the input, we know the input connection and output connection, input side and output side. If input side is forward biased and output side is reverse biased, that is called a active region. The transistor in the active region. Both are in the forward bias. Both are forward means that is called saturation region. Both are reverse bias mean that is in a cutoff region. That's why this is mentioning of the region. The transistor, there has three region: active region, cutoff region, saturation region. Forward reverse na active region, forward na saturation region, reverse na cutoff region. Okay. Then common base amplifier. This is the DC voltage. This is here we give the input signal. Here we are taking the output signal. The working is similar to the common emitter amplifier. We should explain how we give the input, why this is the bias voltage. Then what happens if we are giving the positive. That's why we are explaining the same way of the common emitter amplifier. Okay. Next, we are moving to the common collector configuration. So, in a common collector configuration, the collector is a common terminal between both the input and output. See, here also we note down the input current, output current, input voltage, output voltage. For all the configuration, I only explained about the NPN configuration only. If it is a PNP configuration, just the battery connection, the biasing voltage will be changed based upon the, if it is a PNP, see here, if it is a PNP, emitter is connected with the positive now, and the base is connected with the negative. So if you are giving a forward bias here, negative to just battery connection is reversed for PNP transistor. Just a battery connection only different. The other things are similar only. No need to worry about that. Okay, note down the input voltage, input current, output voltage, output current. We will draw the characteristics. So this is a input voltage, input current with a constant output voltage. This is a graph of input characteristics. Then we move to the output characteristics, output voltage and output current with a constant input current. This is about the output current. Sorry, here I mentioned that the input here this is a output characteristics. Okay, then common collector amplifier. The same way as we giving input signal. Just the configuration, the diagramical differences. Just we are giving another one input signal here. This is a plus the bias voltage. We are also taking the input signal and output signal. The input and output signal is in a alternate current signal. Okay, this is about the common collector amplifier. I hope you people have a clear idea about the configuration and amplifier. What is simply a short revision about the configuration. What is configuration? To use the transistor in application, we should make any one terminal as a common between input output. If you are using emitter as a common, that is common emitter configuration. That amplifier is, if you are using the same configuration as amplifier, that is called common emitter amplifier. If you are using collector as a common one, that is common collector configuration. The same thing used as amplifier, that is called common collector amplifier. If you are using base as a common one between input and output, that is called common base on configuration. Then that amplifier is called a common base amplifier. Okay, fine. Then we know the input and output characteristics. What is input characteristics? There is a relationship between input voltage and output current with the constant output voltage. What is output characteristics? There is a relationship between output voltage and output current with the input current as a constant. Thank you, students. In the forthcoming classes, we will discuss about the other session, power amplifier and other classes. Okay, thank you, guys. We will meet in the other session.